while you were sitting at home with your computer, zooming, having Zoom meetings with everybody, you probably didn't notice, but we entered the European Digital Decade. You know about that? So essentially, the European community is promoting technologies, cutting-edge technologies for people, for democracy, different rules involved. One of the cutting-edge technologies of this decade are digital twins. And given that we are a model-driven development profile, the connection, the brain started to roll, and we started thinking about, okay, what's the future of model-driven development? So we are looking into digital twins, but only not about digital twins for production. We're looking at how to use them for design. So what is a digital twin? It's not a lecture. So just I want to say that is a very, very realistic and complete digital copy of a physical artifact. So you have a physical submarine, you have the exact digital copy of a submarine somewhere in your databases, warehouses, computers, and you can throw everything at this digital model to know exactly, to predict how this product is going to be in the future. I use submarine because I presented it to the other day. But another more popular example is what about, for instance, if you are developing a bike sharing system? We are developing a system where we can take your bike and share it with others. So maybe we are working with this small guy here. So how can we use a digital twin for? This is in fact a digital twin of Karlskrona. This is from our colleagues at the municipality. We have a digital twin of a new area of Potholmen, which is just walking distance from here. So how do we use a digital twin here to improve the way a bike sharing system is designed? So we can use this ultra-realistic representations, for instance, to improve our virtual testing capabilities. We can use it to fine-tune the infrastructure. So where are all the charging spots? What is the best possible place? How they are performing in real time? We can also do real-time data-driven optimization. We are close to the train station. How many bikes do we need here at different times of the day? Can we engineer that with these PSS processing systems? Also, we can have for virtual reality this immersive experiences. So we believe the digital twins are essentially the future when you design processing systems. They provide so many advantages. I mean, this ultra-realistic environment where you can get data from. It's got to be big. So what others are doing? So we did a little bit of a mapping. This is also a diagram that I only understand. I get it. But we did a pretty deep research about, okay, who is doing processing system research using digital twins to design them? Not many, we discovered. Most of the time, digital twins are used only for manufacturing purposes to control things. There is a very, very strong lack of focus on processing systems. Maybe you get people using digital twins to design products, but not to design products and services combined. Very, very few are actually looking at this area here, maybe 3-4 people in the entire world. And there are very few examples. I mean, we were striving for examples, even just to fill up with presentation, but we don't really find them. And what is going on from among the few people that are working with digital twins and PSS? It's a lot about frameworks and methods. It's a lot about that. There's very little about models and tools, which is what we are most interested about. So it's basically nobody, which is basically proposing tools, models, or algorithms, which are very much related to how to create these connections. And something that is really unscientific is that there are many solution proposals with no validation. So it's nobody is validating what we propose. That is quite important to consider. So we started from a ground which is still very slippery, to be honest. We were looking at what others say are directions for future research. And no, it's not really odd to see that entanglement, communication capabilities, data collection, data analysis, these are the things that everybody is looking at when you look at processing systems and digital twins. But a few are actually, and it's not us, they starting to realize that, how do you contextualize these things? How do you actually use them to understand value creation? What are design theories on the back? These are all emerging aspects that are coming up from the research. So this is to say that everything that I'm going to show in the next slide is very much a lot of trial and error popping up. And I have to say, use one company specifically to show digital twins, which is Volvo Construction, because we have a lot of experience with them. And we have some experience, we started to put together the pieces of a puzzle, and I will talk over this video. So we want to develop, for instance, a new generation of these machines, electrical, autonomous, I mean, we heard about them, working in these very confined environments with mines. So we started to work with digital twins, thinking about what we want to throw at the digital twin. We want to throw different configurations of these machines, more battery, less battery, larger, bigger, faster or slower. We started to create different types of configurations, unique combinations of designs through design of experiments, for instance. And when we threw these different machines inside an environment, this is a simulation environment, which is still low level and low resolution. This is a mining site in Stenungsund, but we replicated in a simulation software, which has very limited 3D modeling capabilities. But what we were looking at was the logic of a process. So if we have a machine like that, what is the process? And how much energy is consumed every time we have an activity? These are different graphs of the energy consumption related to, the machines, the power that we use while executing this process. And we were using that essentially, taking data from outside, we were populating the simulation model to know more. Here comes a work that has been done mostly by Julia, and it's about, okay, how we can bring things up to a new level, how we can create ultra-realistic, immersive environments. The simulation before is very low resolution and low level. But what if we can scale it up to make it feel like we are in a mine, or in this case, in a construction site? And we started to develop different types of demos where we tried different approaches, like machines that are working very symbolically. Recently, we are working more with physics-based simulations. We really move rocks and we make calculation out of it. And in the end of the day, we were doing all of this inside the decision arena, which Johan was talking about. These are videos that we have on YouTube since many, many years. But the idea was essentially to play with things. Let's throw a new machine into the simulation. What is going to happen? What is going to be about cost? What is going to be about emissions? And so on and so on. And we use the environment to discuss solutions, proposals, and more. So in the end of the day, we came up with a kind of a map about what are the things that make up a digital twin for PSS design. So there are quite a few things. There is connectivity. We need to connect things, but that's not just enough. We need to create configurations. If you go back to the example of bike sharing, what are the bikes that we are going to use? We need to know how these bikes are used. We need a logic, and process simulation is just for that. We need to show people what is really happening in Karlskrona and not in Eskilstuna or Trollhättan. We need the environments that are very ultra-realistic, and that we do with gaming engines. And then we need to boil it down to somewhere where we do the calculation and we find out the best. And we still have documents in our company. We have use cases, functional models, and everything slowly started to connect. We have different connections here in order to be able from these inputs to get to a decision down here collaboratively with everybody. This is for the bike, and this is for construction machines. It's the same kind of logic. You have simulations that drive everything. You get a number, different numbers, and you take decisions on the basis of this information. I will not go much further into this because I have only 10 minutes. You are just to mention that we are looking at all this architecture about digital twins, working on 4 different layers. This is something that many of you have been seeing also when we were talking about a few months back of this doubled application. And the whole idea is that digital twins for design, not digital twins for manufacturing. We need just to move forward from the idea of modeling and twinning products. It's not just about putting a sensor and getting data. It's about also understanding, okay, what is the process and why is this data is produced and this data is representing what? And I think Carl this morning present very well the challenge of getting data to understand value. This is very much about getting data analytics to understand what's the value of this machine in that particular process. And also, as Tobias is going to present later, and more contribution will come, how to visualize all of this. So we engineers take a decision, and on the top of it, how do we actually create and put together many different twins to create and to find something that is a little more unexpected. So maybe we find something that is unexpected by just putting together as much information as we possibly can. So next step, but that will be the final presentation, is okay, Let's bring this architecture live and make more into this environment and see how this ultra realistic representation is really going to work.